Hello, everyone. Welcome to today's Power Corner. I'm your host, Ali Ashoka, the editor-in-chief of Power Electronics News. Today, we're speaking with Cédric Malaquin, the director and analyst for RF, analog, and power at TechInsights. So, Cédric, welcome. How are you doing today?
Yeah, very good. Thanks for having me.
Yeah, so I read the TechInsights 2026 power outlook and was struck by the section on silicon carbide commoditization and consolidation. Can you cover a little bit more of the background on the SiC market uncertainty and the different paths taken to maintain profitability?
Yep. Yeah, that was also something we wrote, last year, end of last year,
Yeah.
trying to project the following year. And the market situation at the time was the industry broadly highlighted, transition year for the silicon carbide industry, marked by inventory levels, underutilized capacity, and also the declining wafer price, which have been some of the issues. One other thing we've noticed also is the lack of visibility into the customer demand, which has driven kind of a last time buy behavior at the customer side, and has also been a concern to the industry. So what we do see now is the growth in automotive electrification is expected to moderate quite a bit in China, in North America, particularly. This is due to the declining tax incentives and also the high penetration rate that is already there in China. And this is why I think the industry remains cautious about, adapting its supply footprint and also trying to cut the cost structure. I think, however, despite the softer regulation and reduced incentive that we just discussed, the new BEV platform that have been, initiated before that, they were being developed. They are due to be introduced in 2026, 2027. So therefore, we still estimate that the BEV market will be a traction for this industry. And especially, I think in Europe, this has been delayed for quite some time. I believe for this year and the next one will be the time you will see the market taking over and becoming a growth driver, kind of, catching up and replacing a bit what happened in the China market in the last few years. I think the other big market for silicon carbide is the renewable energy market. And this is a field where we've seen a strong market growth from 2023. Again, for this one, I believe the moving into 2026 and beyond, the growth will probably moderate a bit because we reach a step, particularly in the China market. So this will be I think probably a big market, but more a stable one that we will see happening. And next to these growth opportunities, we have the next growth pillar is expected to be the data center power supplies, as the power density in this segment is increasing quite dramatically. And next to that, also the strengthening of the power grid is the other field where we expect some great momentum moving forward. And that's an interesting prospect to follow.
Yeah.
And this is pretty much what we documented in our last data center market report. So we sized the opportunities for the power semiconductor market overall, also providing the boundary conditions, because, given the growth that is expected there, everybody asks, is this sustainable? Can we deliver on that? So those are things we are also addressing. And based on that, we extracted the share for silicon carbide, what we can expect in the next 5 years. So we do believe all in all, you have a bulk market, which is pretty much the automotive and the renewable energy, and the growth coming from the data center market. So to get back to your question on profitability, I think as companies get improved visibility on their legacy market and the they see the top line growing from the data center market. They will restart increasing their fab loading. And this is really the first order parameter to their profitability. And next to this, I believe the transition to 200 millimeter likely will improve the economics of silicon carbide in the midterm. And yeah, this is the die level discussion. And last point I would like to mention and to stress is really you have an emphasis in this industry to go with more value in your product, and this is where you see the SiC module also taking more share on the market moving forward. So this is obviously improving, the company's margin profile moving forward.
Okay. And you were talking about, the move to 200 millimeter, and I read that there was also innovations to improve device figure merit and strategic shifts away from the EV market to, strengthen silicon carbide's long-term position. Are there other are there vendors or market approaches that you believe will have the strongest long-term positioning?
I think this is really to me, the move toward 200 millimeter is likely the most efficient and promising approach to improving profitability in this market. Much of the commoditization we've written, in the Outlook report and before that, I believe happened because of a growing number of companies pursuing the silicon carbide business at the small wafer diameter, so like the 6-inch wafers. And I think only the leading player will be able to achieve process transfer at 200 millimeter with sustainable yield. And this is, I believe, what will drive, the winner for the next few years. Another point, I think, scaling to 200 millimeter is a strategic move in a way, in the sense that the wafer is just scaling, the supply chain is just scaling. Now, 6-inch wafer are still the, the main volume. So this is somehow locking the capabilities and the allocation to the more advanced players, at least for the next 2 years, before 200 millimeter become mainstream.
So, and you actually already mentioned this beyond EVs, which emerging SiC application segments could reshape the competitive landscape. You were saying that renewables and EV are the bulk markets, and data centers are increasing there. Is there anything outside of that you're seeing?
So yeah, we mentioned the data center. As you said, this is really the power supply, the UPS and the battery backup, and the protection element like the solid state circuit breaker and the solid state transformers. So those are really the things that are driving the growth as we see. Other application beside that really is the grid reinforcement that is required to deliver this new amount of power to the industry. So I would say those are the main two which we see moving forward. And there you have also different kind of niche applications. They were there already, they will remain. But beside that, I would say no additional thoughts on the next growth drivers so far at this stage.
Great, thank you. Maybe we can shift gears to GaN. Because that was also covered in the report. Can you describe how GaN vendors are mastering their tech through innovations around epitaxy and buffer layer engineering?
Yep, that's really a key asset of a GaN player. So the epitaxy material engineering, I would say, is the centerpiece to device reliability to power device, and that's also a differentiation lever that they are using. I must give credit to the technical team who made a lot of analysis in the field. They put together a featured content comparing different epitaxy structure for from different vendors, which give us some information about the process. So that's including, TSMC, Texas Instrument, Infineon, InnoScience, or EPC. So the minimum structure that is required for a GaN device, you have, the nucleation layer via aluminum nitride nucleation layer. Then you have a GaN channel layer on top, which contains the 2D gas electron. That you have the current conduction into it, and next you have the AlGaN barrier layer. But I would say the magic really happens in between the nucleation layer and the GaN channel, where you see different approach and often combination of different approaches. You have graded AlGaN layers. You have AlGaN superlattice that can also be used and often combined. And in between, you can also have a GaN buffer layer, which are kind of sandwich in between these layers. So I'm not getting into the details who is using what. I think this is pretty much proprietary information, but our subscriber can get access to this kind of information. So this is really the key where we see, people, developing their products and building around. The last point for the GaN really is on the gate leakage, which is another field which is addressed by the industry. So with, new dielectrics being used and different techniques for the deposition methods, passivation layers, things like that, that are improving the reliability of the device.
I know you didn't want to get into it too much, but I am curious, what's the most popular kind of GaN IP or the most maturing technology in that magic layer, as you were saying, between the nucleation and the GaN channel layer? Most popular. Okay, we don't have to. We don't have to.
Maybe I would just comment that the superlattice is really super popular.
Okay.
Topic being used.
Yeah. Okay. Maybe we could shift to monolithic integration. It's a key enabling factor for GaN, integrating drive, sense, and protection. How do you see this changing the playing field for GaN, and what are the main applications that this could impact?
Yep, that's a good question. I think this is probably a game changer for a number of applications. Monolithic GaN power IC, that's integrating the power FET and the gate drive. Some logic around the protection and also the sensing, current sensing, things like that really protect the device to, fail or being damaged. That's also eliminating the parasitics that come along, with a co-packaged device. You have a gate drivers and the dies next to it. So therefore, you can, with these ICs, switch faster than what you can afford with co-packaged devices. That's also much simpler EMI design that you can utilize, and more compact form factor. So I think this is really something that is lowering the entry barrier, market acceptance for this GaN device. That's also opening the GaN material to non-specialists, I would say, to use also the GaN device. And I would say this is the approach that basically accelerated the acceptance of GaN in a consumer market like the USB-C power delivery charger. And next to this market, probably other market opportunity will arise. I believe data center-wise, most likely we still see the discrete kind of approach being used, because you require very specific power pattern, and you need to also
I hear that 300
design the
millimeter GaN will potentially enable more of those data center applications, more integration there. But might have more information there.
That's also something to be considered. Like you switch to the 300 millimeter, you can also have more advanced technology nodes and more robust process flows that you can certainly accommodate better GaN ICs. But my point is more the industry working around the data center. They are more the specialists, having the knowledge for making the design functional. And we are not in the cost optimization and GaN democratization that I was mentioning earlier. So
so let's talk about GaN 900 volts and beyond. There's that pressing question about GaN pushing into silicon carbide territory. How do you see this market developing, and do you see this as a serious market contender in higher voltage EV systems in the next 5 years?
So there are multiple approaches to GaN for higher voltage. One of the approaches is to use the thicker layer, obviously, for the drift layer. But that creates some problems, some issues with the wafer warpage, things like that. So therefore, people are using different substrates. So either sapphire type substrate, which can be an approach. And it's also something that is leveraged by players like power integrations, for instance. You can also think about using the chromis type wafers also to enable temperature compensation of the substrate, or CT mismatch compensation rather than temperature compensation. That's also one other approach which the industry is pursuing. And next, you have a vertical GaN. If you want to scale to much higher voltage support and power rating, you can use this vertical structure because they are really scalable to this domain, and they have the avalanche capability the industry is looking for as well. So this is definitely making them good candidate for EV systems, and also provide the ability to switch at much higher frequencies compared to what is used today with silicon carbide. But that also means you need to completely redesign your system. And we believe this will take time for the designer to take that approach, put them into system, completely validate system level performance. I think it will probably take some additional years to get there. And cost-wise, I would say, last point, vertical GaN was probably limited by the cost of the substrates, which was 4-inch at best. But so far, this will improve as we move forward. And again, credit to my peers from the technical analysis side. So they released a report that also show the different approach for addressing vertical GaN and pros and cons of the different architectures. I think would be worth to watch.
Yeah. GaN bidirectionality. Sorry. So GaN's inherent bidirectionality has been taken advantage of with GaN BDS. How do you see this developing, and where are we seeing initial commercial adoption? What are some future applications there?
So for GaN bidirectional, I would say there are literally different approaches. Inherently, the GaN can be used as a bidirectional switch because you can, have both directions. But that applies for the low voltage and mid voltage type device. If you go to high voltage device, then you need to have an extended source region to avoid, a breakdown of the device. And this is where you need to apply a specific design like dual gate transistors that have been developed by Navitas or Infineon that we've seen recently. And I think this approach is really interesting to enable application where power flows in both directions. We've seen, the applications like commercial microinverters, for instance, which is one of the early adopters for this GaN BDS device. Moving forward, I think this is an interesting approach for any kind of system that is exchanging power in both directions, like a BESS system in a data center could use this type of approach. You basically replace back-to-back switches with this GaN BDS. That's also is interesting to, bill of material optimization.
Very cool. Maybe, beyond the devices themselves, how mature is the supporting ecosystems? So, reference design, simulation models, field application support for both, vertical GaN and bidirectional switches.
Yeah, okay. For bidirectional switches, I would say there are probably a lot of push on this device. Those have been developed and highly come with, supporting material, education for designer to use. Reference design, you also have webinars that also explain the benefit of the technology, how it works, what to do with them, how to plug them into a system. So I think GaN BDS is probably close to maturity to get, mass market adoption. When it comes to vertical GaN, I would say probably it's a bit early to see, similar maturity level. We expect similar campaigns, to support the technology adoption. I think now what we'll see probably in the next coming years is the proof of concept and also the different figure of merit that needs to be validated before, any designer consider having them integrated in a system.
Let's close off with China. So China's wide bandgap push, there was a lot in the report there. So how do you see this impacting? It's a big question. How do you see this impacting global competitors? What are the methods you see established suppliers pursuing to combat this threat?
Yep, that's a great question, something we track really closely. China made it clear that wide bandgap technologies were a strategic priority. I think it was some time ago. And this is, I think, an area where there are fewer constraints in wafer fab equipment procurement compared to, advanced silicon nodes. So also explaining why they're pushing on that. Still, I think the wide bandgap material are critical for e-mobility and the electrification of the industrial and energy sector. And those are fields where China has a strong position and also is very likely to push on having a local ecosystem. This is, I think, justifying why the Chinese wide bandgap suppliers have heavily invested in the field, in capacity allocation first, and then in product development as well. They are ramping as we speak on multiple products, and they have automotive grade samples being delivered to customer and waiting for qualifications. So I think we are not there yet, that they take over the market to legacy player or, leading player that we have now. But that's progressing, and that's something we track, as I said, quarterly through our power semi market share product. I think adapting to this, the leading players probably are watching the type of application they want to address. They are clearly moving away of commoditizing markets, things like, entry-level grade SiC. They are no longer making, and they will no longer make. And if you look GaN, for instance, it's the same. That's what happened in the mobile fast charger. You had initially the Navitas and power integrations they pretty much all step back from this market because of the presence of the InnoScience and others that also taken most of the share here. Another thing I think they are making, some of them at least, they are pushing a China for China strategy. So getting resources directly on the mainland China, also being able to be qualified and managed as a Chinese supplier. So that's one of the aspects. And I think the last point I would like to make is about reinforcing the product development in fast-growing and high added value applications like in the data center space and also the power grid reinforcement, improvement.
Okay. Well, thank you so much, Cédric, for your time. I'm probably going to tie things up here. It was very illuminating, a very helpful conversation. Very interesting perspectives and outlook on the wideband market. So I appreciate your time.
My pleasure. Thank you.
Thank you.
Bye.